It is an honor and a pleasure to be here to share with you the important work that we're doing in partnership with the FSHD Global Research Foundation. Our goal at Springbok has been from the get-go to develop technology to empower people to understand the inside of their bodies, in particular their muscles, which of course we all know are important if we're here today. To start out, so I am a professor, so we're going to start out with a little professor time. We all use hundreds of different muscles in order to do our daily activities, from walking to smiling to reaching for things and many other things. It's actually amazing that we do those things. We don't even realize how many muscles are in our body and how they're working together. So I'm a biomedical engineering professor, and I've spent my entire career fascinated by that process, fascinated by human movement and how it works and how muscles really work. And there's many other people like me out there. So why is it fascinating? Why is it complicated? Many of us do it. We don't even think about it, right? Well, let's just start with one example that is really relevant today to this event. So for each function that we have in the body, many muscles have to work together. So here's an example, rotator cuff. Rotator cuff muscles are in the shoulder. We think about rotator cuff muscles a lot in the context of rotator cuff tears. Many people get them. It's very common. We have surgeries. Did you know that there's actually 4 different rotator cuff muscles that comprise that group? And each of them are different from each other and have very different structures and unique functions relative to each other. Similarly, I think many people here may have at some point have a sore hamstring or torn a hamstring, right? Well, it turns out hamstrings is 3 different muscles. 3 different unique muscles that work together to perform the function of the hamstrings. And actually, there's people in my field who spend their entire career studying one of those hamstring muscles because it's so unique. So that gives you a sense of how complicated the system is and how each muscle serves its purpose. But you may be thinking already, well, most of the tools that we have today look from the outside, right? If we're trying to understand if we're having an issue with our knee or strengthen our knee, you can just look from the outside. But now you're realizing that for that one knee, there's over 10 muscles that are crossing that knee that could be the problem, right? We just talked about the hamstring. There's many other. So how do you know when you look from the outside if a movement is impaired, which muscles are causing the problem? That's really the problem here. And this is the problem that we at Springbok have aimed to solve through actually decades of research and innovative AI development. So at Springbok, that is our goal, is to develop technology that we have and implement it in a wide variety of applications to give information about each muscle in the body. So it starts with a very rapid MRI scan, shown here, and so it can't end there because you look at that MRI scan, that's not giving you all that much information about each muscle, right? Well, this is where the AI comes in. So we go from that and we find every single muscle in that body and at every single point in the body, and we can develop this 3-dimensional digital twin of that person. Where we see their muscles in 3D. And not only can we see it, but we can quantify very important metrics about each muscle. And so relevant here, what we've shown here is we've quantified the fat infiltration, which is a measure of disease progression. So as the FSHD progresses, muscles go from a very low level of fat infiltration, which is the tan color, to a very high level, which is this orange color. So we've mapped that on so you can see it visually, which makes it intuitive. We all have bodies and we understand them. So we see here a patient with FSHD, actually from the FSHD Global Registry Project here, where we see a wide range of involvement there. Then in terms of how this is used, we also can deliver the information in numbers that are often used by researchers or clinical trials, but then also in ways that people can actually access the information through an interactive 3D viewer or a report that can be shared with a clinician, perhaps. Oopsies. So one finding, so we've been doing some scans already, thanks to this community from last year. Now we've done many of these scans in terms of developing these clinical trial passports. So we thought, well, one question let's answer. Since these are some of the very first full three-dimensional, full-body scans at the individual muscle level that patients with FSHD have had, thanks to you all, we said, okay, well, which muscles are actually affected? We've already heard the term facioscapulohumeral muscular dystrophy. It's a big mouthful. But what does that mean? It means face, it means scapula, which is in the shoulder, and then humeral, which is in the arm. So that implies that those are the muscles that are affected, right? And so if you didn't know what FSHD, like anybody, you would look it up on Google and you would find this Wikipedia page that shows the picture of which muscles are commonly involved in patients, right? This is what the disease looks like, is what this is telling us. The question is, does it? Well, let's look at some examples. These are a range of examples of patients with FSHD from Australia, showing which muscles, and again, this is this color coding where the orange means very high level, where we see, number one, many muscles affected. And if you remember that image, it's not only those specific muscles in the shoulder and the arm. We don't have the face muscles here, but the face. But we see in the core, we also see in the back, we see in the leg, we see many different patterns, number one. So pretty much any muscle can be affected. And then number two, everybody is extremely unique. Everybody looks different from each other. So it's important to understand, we think, that actually FSHD isn't just specific muscles, it's really the entire body. So we're starting to advocate for enough with the FSH part, because that really minimizes the impact of this disease on these individuals, because it can really affect so many muscles and many aspects of their daily function. So the power of this data, we were just hearing a little bit about this, and we're going to hear more about it from Emma Weatherly, but we are developing what we call a disease progression model, which takes into account all this detailed information and now can predict for each muscle what is going to happen in the future. Because since everybody is unique, it's very hard to design a clinical trial to figure out if a drug is working, because what do you test in each person? You can't pick one thing, because in one person, the disease is going to progress in one set of muscles, and another person the other. And actually, there was just a recent important announcement. The first phase 3 clinical trial in FSHD actually proved to have a negative result. And they ended the trial because, and we believe in large part because they had the wrong endpoint. They didn't have an endpoint that could really understand the impact of the treatment on the disease, which is a big bummer in terms of progression. So we are trying to really work hard to develop a new way to do this that can make future clinical trials successful. The other one is that we're supporting this, of course, this clinical trial passport. So by having the scan, individuals be ready and understand their bodies. They'll also have a good sense of which types of clinical trials may benefit them and in how. And then lastly, these scans can actually be useful to individual patients. This is a good example of a patient who took the scan from their clinical trial passport. Their physio actually laminated it, and they brought it into the pool, and they're using that to guide their physical therapy, which is amazing and incredibly creative. I love that. I find Australians to be very creative. This is a beautiful example of that. So these types of reports are very intuitive, and they can actually be used by individuals to understand where they're going. The other interesting thing that I thought I'd point out is that the same technology is being used in elite athletes. So right here in Australia, we're working with Cricket Australia and also Australian rugby league players to do a very same type of analysis of scan to understand their bodies and how to help them, whether it's recover from an injury or improve their performance. Because ultimately, everyone is an athlete, believe, and everybody's trying to make the best use out of their own bodies. Oopsies. So with that, I want to thank you for your attention, and thank you for all your generosity, and thank you for the FSHD Global Foundation for all the important work that you're doing.